All right, the last little bit we have with complex numbers is how this thing might actually pop up when we're solving equations. First place we see it pop up is when we are dealing with quadratics. And when we're solving quadratic equations, sometimes we see the square root of a negative pop up, which is this complex number idea. So recall that the solutions of a quadratic equation ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0, are given by the quadratic formula. The radicand b squared minus 4ac is called the discriminant and tells us whether the solutions are real numbers. In particular, if b squared minus 4ac is less than 0, the solutions involve the square root of a negative number and thus lead to complex number solutions. In all, there are three possibilities, three cases in which we can summarize. When the stuff underneath the square root is greater than 1, or greater than 0, excuse me, we have two distinct real solutions. So like we'd have the square root of 1, so plus 1 and minus 1. If the square root of the stuff was 0, there's only one real solution because the square root of 0 is 0, and adding 0 and subtracting 0 are the same thing. Remember, that's what we're doing with this discriminant. And if I had that b squared minus 4c is less than 0, now we have a complex situation going on because we have a positive and a negative of a negative square root. So we are producing a complex conjugate. Okay. So here we go. Solving a quadratic equation, you can be using the quadratic formula. You can use completing the square. If you're trying to graph, though, you're going to see that these graphs do not touch the x-axis because there's no real solutions. So what I'm going to do is I'm just going to use the quadratic formula. It's probably going to be the easiest in this case. So negative of b, which is 1, plus or minus the square root of b, which is 1 squared, minus 4 times a, which is 1, times c, which is 1, all over 2 times a, which is 1. And in this situation, you got really lucky, a, b, and c are all 1. So I end up getting negative 1 plus or minus the square root of 1 squared is 1. 4 times 1 times 1 is 4, so I get minus 4. All over 2 times 1 is 2. So I get negative 1 plus or minus the square root of negative 3 over 2. And the square root of negative 3 is a bad number. I'm going to take this and break this into negative 1 and 3. This negative 1 comes out and becomes an I on the outside. The most common way of seeing that written would be negative 1 plus or minus the square root of 3. And there's your I afterwards. And there would be your solutions to this quadratic equation. If I really, really, really wanted to put this in standard form, you would see this written as negative 1/2 plus or minus the square root of 3 over 2i. They are the same, slightly more proper here, but the idea is that we have two solutions, one where we have plus this imaginary portion and one where we have minus this imaginary portion. All right, what I'm going to ask you to do right now is you're going to try this once. This is something you did last year. You're going to take this quadratic. You're going to solve either by using the quadratic formula or completing the square. And you are going to give me the solutions, which are going to be complex conjugates of each other. All right, after you go ahead and plug this in the quadratic formula and simplify, you should get all the way down to the point where in standard form we get 1/6 plus or minus the square root of 23 over 6i. And there's kind of a refresher on complex numbers and just kind of a refresher on what we're going to be seeing this year when we're dealing with solving polynomials.